Hi everybody, and welcome to our third video on integration by parts. In this video, we're going to explore another technique involved in using integration by parts. This time, there will be a product in the integrand, just like in our first video. However, when we do integration by parts, we're not going to get to stop as soon as we get to our next integral. In fact, we're going to have to use it again. Now, there are instances where you can use integration by parts 2, 3, 4, 100 times. But we're not going to want to do it that many times here. In this example, we're going to stop after a couple times through and see how we can actually sort of find the answer kind of going through the back door. So here's our example. We want to find an antiderivative for e to the x times the cosine of x. Now, unlike in our first video where we looked at x times e to the 5x, and after we used integration by parts, that x went away. Here, when we use integration by parts, neither term is really going to go away, right? Taking derivatives of e to the x just gives you e to the x. Taking derivatives of cosine or antiderivatives would just give you sines or negative signs. We're not going to be able to get rid of those functions, all right? So we're going to play a trick, and we call this the I trick, okay? Not I like here, but I like this. And the only reason we call it that is because we're going to name the answer to this problem I for integral, okay? But this I trick is going to be very, very handy when we have two different functions multiplied together and neither one of them wants to go away when I differentiate or anti-differentiate. All right, so let's see what we're going to do here. First, I'm going to label, say, my e to the x as u and my cosine of x dx as dv. So let's see, we'll make our little table. So u is equal to e to the x, and dv is equal to cosine of x dx. Now I need to, of course, find my du. Okay, the derivative of e to the x, that's just e to the x. And then we have our dx. And I need an antiderivative for cosine, and that's sine. Okay. So once I've done this, I can use my integration by parts formula. Again, let's remind ourselves, antiderivative of u dv equals uv minus an antiderivative of v du. So let's see. I have my u dv, and so I need to replace with u times v, so e to the x times sine x, minus an antiderivative of, well, I need my v du. Okay, so that'll be e to the x times sine of x dx. All right, so the good news is I got rid of my e to the x cosine of x. The bad news is I have an antiderivative now of e to the x times sine of x. I don't know how to solve that one any more than I did the original one. Okay, fine. We try integration by parts again and see if maybe things get better. So let's try it over here. I'm going to take just this part of the integral. And let's see, how about my e to the x? That can be my u. And my sine of x times dx, that will be my dv. So we'll make a little chart. So u is equal to e to the x. And dv is equal to sine of x dx. So du is equal to e to the x dx. And v is equal to, be careful, antiderivative of sine is negative cosine of x. A lot of people want to just say cosine of x. Okay, fine. So I can copy my e to the x sine of x minus, now I'm going to put some parentheses here because this minus is going to have to hit two different pieces. All right, and I want those parentheses there to remind myself of that. Okay, so I need my uv. So let's see, I have a negative e to the x cosine of x. So negative e to the x cosine of x minus an antiderivative, my v du. So this is going to be, well, let's see, negative e to the x cosine of x dx. Negative, e to the x cosine of x dx. Close our parentheses up. Okay, so there's a lot there, so let's do a little simplifying. So I have e to the x sine of x minus is plus e to the x cosine of x. Then I have minus, 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 so three minuses is a minus, antiderivative of e to the x cosine of x dx. All right, so I started with a problem I didn't know how to solve. I converted it into garbage minus another problem I didn't know how to solve. I converted that into even more garbage minus my original problem. This is the problem I started with. And so you might think, well, that's a complete waste of time. But amazingly, it's not. From here, we can immediately write down the answer. What? Yeah, it's craziness. Okay? So I have I, and let's just move that I over here. I equals garbage minus I. So I can add I to both sides. If I add I to both sides, then I get two i's, right? Add an I over here, it gets rid of this minus I. Add an I over here, I get 2i. And I'm left with e to the x, let's factor that out, times sine of x plus cosine of x. Okay, but I wanted I, not 2i. No big deal, I divide by 2. I is equal to a half e to the x times the quantity sine of x plus cosine of x. And of course, at the end, we need to go back and add in a constant of integration. So this is really, really wild. We used integration by parts once and again, and ended up with the same problem we started with. The only difference is that, well, now it was minus I instead of plus I, and somehow all this shuffling gave us the answer. We were able to find I. This is really, really wild, but really, really effective.